All right, let's go over these. Hopefully you were able to at least get through A, B, and C. So this is just good review for the quiz tomorrow. Let me darken this in really quick. So what does the minus mean again? From the left. We've slept a lot since we learned that. So from the left. So as x approaches 0 from the left, okay, that would be right here. So what did you get for that limit? -1. Okay, what about the right-sided limit? -2. Now, did it matter which one was a point and which one was a hole? No. When you're trying to find limits, it doesn't have to be a hole, it doesn't have to be a point, it could be either one. Okay, now because the left and right-sided limits are not equal, what do we know the answer for C has to be? Does not exist. If they were both the same number, then that would be your answer for part C. Okay, what about D? Approaching 2 from the left. 2. Approaching 2 from the right. 0. Again, these two things are not equal, therefore the limit does not exist. If they had been the same number, then that would be your limit. Okay, graphically, what are you looking at when you're trying to find g of 2? The actual point, right? This is where you're not going to look at a hole, you're going to look at a point. And so that would be right here, and that y value is 1. And this is important because when you're doing continuity, which we'll review here in just a minute, you know, your limit needed to equal your point for continuity. And then h was just another limit. As t approaches 4, the y value approaches 3. Okay, so that's just a little bit of review on how to do one-sided limits on a graph. You know, I'm not reviewing, this is not like a straight up review for the quiz, but I just wanted to kind of hit certain topics. I want you to turn to this page. Actually, sorry. I want you to turn to this page, which I think is just the next page. And I want you to go down to look at example 1 one more time. When you're being asked, is something continuous? Or prove that it's continuous, or show that it's continuous, there were 3 things you had to show. And on the quiz tomorrow, I actually help you out, and I put 1 blank, 2 blank, 3 blank, and then I go therefore blank, so that you know you are not done until you fill out all those things. But what you have to do is prove that the limit exists. And a piecewise function, that's the left-sided and right-sided limit, and we're going to practice another one of these in just a minute. And that's usually the hardest step, is proving that the limit exists and what it equals. The second thing you had to show was what f of the number was. And this is where you look for the or equal to. Okay, you had to show what it equaled, show that it exists. And then the third thing was just stating the obvious, that they're equal to each other. The limit is equal to the point, therefore f of x is continuous. Now, if any of these are not true, then you would say they're not continuous. So I want you to skip to number 7. On the next page. And so again, we're going to start with the first thing, which is the left-sided limit and the right-sided limit. Okay, which of these two pieces are we going to use for the left-sided limit? The first one, right? Not because it's first, but because of the less than part. So I'm going to go ahead and write 1 plus x squared, and now I'm going to actually plug in 1. 1 plus 1 squared, that's 2. You do have to simplify here, because in a minute, when I find x approaches 1 from the right, we're going to have to show that these two things are the same or that they're different. So we're going to plug this into the other piece. 4 minus 1 is 3. All right, now, when these two things are equal, that's your limit. And then we would go on to condition 2 and then condition 3. But these two things aren't equal. So we would stop here, say the limit as x approaches 1 of f of x does not exist. Therefore, f of x is not continuous. So the not continuous problems are actually easier. Don't forget that at x equals whatever number they tell you. The not continuous ones are easier because you end up doing less work, because you stop as soon as either the limit doesn't exist or the point doesn't exist or whatever. Okay, so you have a lot of examples now of this whole continuity thing. Please make sure you're prepared to do a continuity proof on the quiz tomorrow. Okay, I think we did not also do this last example here. So number 9. I'm going to leave 8 showing because we're going to use a lot of the same ideas as we used on 8. Remember we said we want the first and second piece connecting at x equals 0. So we set the first and second piece equal to each other and we made x equal to 0, and we said, oh, if those are equal, then we have continuity. It's this isn't a proof. It's the same kind of mathematical steps, but this isn't a proof because the question isn't saying show that it's continuous. It's saying just find the values of x where it's not. So they were equal for x equals 0. Therefore, we do have continuity at x equals 0. However, for the second and the third piece to connect at x equals 1, those were not equal. So we have not continuous. So really my final answer here was just x equals 1. So then for number 9, it says for what value of the constant c, so my answer should be c equals something. Is the function f continuous? I want it to be continuous, and then this just means for all numbers, okay? So where we're really concerned about it not being continuous is right here at x equals 3. This is really the only place that we might have discontinuity. So what do you think we're going to do with that 3? Plug it in for x. So c times 3 plus 1 and c times 3 squared minus 1. And if we want it to be continuous, we want these two things to equal each other. And notice I didn't plug 3 in for c, I plugged it in for x, because that's what 3 is representing. So if I kind of rewrite this, 3c plus 1 and 9c minus 1, you got to solve this equation. There's lots of different ways to solve it. I'm going to subtract 3c. That's going to make 6c. I'm going to add the 1. And so that equals 2. So therefore c is 2/6 or 1/3. These types of problems, although they're weirder, are actually, I think, easier because you don't have to prove anything. You're just, like, I think it's less work. That's an opinion, though. You might like the proofs because it's the same thing each time. Okay, so that was just kind of going over some stuff that we didn't do before and a little bit of review. Like I said, I didn't review everything that's on your quiz tomorrow. But if you did the homework, you look back over your notes, you're going to be totally prepared.